So I will try to remember to record every session. If I don't, remind me. Okay. And at the end of each session, I will email it to you along with your homework. I try to send the homework one day or the weekend before or the day before, just so you have the worksheet so we can look at it together. When I send you the worksheets, they're never due until after we lecture about it, right? So there's never a time where here's something, he didn't show us this before, and then you have to do it. Okay. So let me just introduce myself. So you can call me Dr. Kawhi, or you can call me Professor Kawhi. Some of you have had me here in TEAS before. Some of you have had me in other classes. So not everyone is new to how I work. So for those of you who have never taken a workshop with me or never taken a class with me, the way I work is that I can't see the chat and I can't see the raise hand like icon. Just interrupt me. So while I'm in the middle of stuff, and if you're at all confused, just go, I don't understand, how come? How do you do that? Explain that again. I will re-explain everything. Okay. So you don't have to worry about, I'm going to get mad or I'm slowing things up. It's my job to keep us on pace, and I will. It's your job that every time you're a little bit confused, you just interrupt me and go, wait, explain that again, say that again. I don't understand. Could you help me out with that again? Okay. Everyone clear with that? So just interrupt me. You don't have to worry about, I just interrupted him. Is he going to get mad? Do I have to wait another 5 minutes for asking another question? The answer is no. You can ask and ask and ask and ask and ask. Usually my best workshops have, 1 or 2 students who are just really aggressive about becoming a nurse, who really couldn't care less about anything else other than, I don't want to be confused. I never want to take this class again. And every time I'm a little bit confused, I'm just going to ask Dr. Kawhi to stop a second, and then ask him to answer some questions, and I'm gonna. Okay, so please stop me anytime you have a question. Okay, now we're going to work on a couple things today. We're going to work on ratios. Unit conversion. And translation problems. Okay. So ratio and translation problems are word problems. Now, the way the TEAS works is that there is some questions you just can't study for. You kind of know it, you don't know it. They're just sort of trick problems, which kind of combine 2 questions in one. So there's not really a great way to study for it. You just kind of hope you know it. And remember, on the TEAS, you get to guess. So you just guess and hopefully you're right. Okay? Now, what my strategy is that in the TEAS, you only have to get 2 out of 3 questions right. So what you want to do is you want to focus on what are the questions that are always there, and what are the questions that, with a little bit of information, I could have gotten right. So hopefully you looked at last week's video, because last week's video will ask you, is that an irrational number or not an irrational number? Okay. It'll ask you, order these numbers from biggest to smallest. Okay, so whether something is irrational, rational, or real, that shows up like on every exam, and this comparison shows up on every exam. So if you didn't look at the last video, please watch the last video because you're gonna have to do a lot of unit conversion. And this comparison of numbers is something that they like to do. And it's one of those things where you watch the video, you should be able to do it. And it's two questions that students normally get wrong that they'll likely get right on this exam. Okay, so let's get started. So let's start out with translation problems. Okay, that's the one that usually takes the longest. Okay. And then I'll send out the homework. The homework will always have solutions connected with it. If you go like, well, why is it homework if there's solutions? Can't I just copy the solutions and send them to you? And the answer is, sure. You can absolutely 100% cheat the process. Doesn't mean that you're going to become a nurse, but you can 100% cheat the process. The reason why I send you the solutions is that you should never practice errors. Meaning that every time you do a problem, check the answer. Every time you do a problem, check the answer. If you are doing wrong problems over and over and over again, it just becomes concrete in your head. And then it takes longer to unlearn it. So the reason why every worksheet has solutions, either on the bottom or on a separate little file that has the solutions on it, is that I don't want you practicing errors. Okay. So before every workshop, email me your homework so you get your ticket to attend the next one. Now, sometimes stuff happens, right? Life happens. So if something happened that puts you in this unfair situation, just text me, let me know, and or just email me, and that's fine. Or just come and say, hey, Dr. Kawhi, real quick, I'm going to DM you in the chat. Something happened. Is okay if I can be here? And I'm probably going to tell you, yeah. Okay. My mom got sick. I got sick. If something happens where it wasn't just you being lazy, but I'd like to attend the next workshop, then yeah, sure, just let me know. I don't need documentation. I don't need something from the hospital. We're just trying to get you skilled so you can like go on to the next stage. Okay. And just so you know, there's a few students who made it from this TEAS workshop to the nursing program, and they're in my nursing dosage class, and they're really excited. It's just a different life, right? Let's push ourselves and let's like stop being in limbo. Okay, so let's work on translation problems. Now, what translation problems look like is they look like 5 less 2. What's that equal to? Now, we want to compare that with something that looks like 5 less than 2. They mean two different things. So if someone says 5 less 2, this is the same thing as saying 5 minus 2. Okay. We keep this in the same order. Same as if we said 5 subtract 2. We keep it in the same order, right? 5 comes first, 2 comes next. Now, if we have something that says something like 5 less than 2, then what we want to do is we want to reverse the order. It's not the word less that makes us reverse the order, it's the word than. Also, if we say 5 subtracted from 2, The word than and from tells us to reverse the order. Than and from. So the word than and from means reverse the order. So also if I say 10 divided from 2, we're going to reverse the order because it has the word from. So then it'll be 2 divided by. Whereas the word 10 divided by 2 is 10 divide 2. So all of these, because they don't have the word from and then, these are the same order. Give me 1 second, I'm gonna turn off my heater. Oh, and then one more thing. Unfortunately, I have a visual processing thing. So sometimes you'll see me miscopy or flip words. So if you see me do it, just tell me like, oh, that's why 5 plus 2 is not 8, it's 7. I'm like, I'll go, oh, okay, thank you. So if you see me miscopy something or misadd something or multiply something, it's just because my brain sometimes sees a different letter or a different number. Just tell me, it doesn't hurt my feelings. People have taken my class, they'll go, in the beginning, they go, that's weird. And then you just get used to it. You go, no, 3, not a 4. And I'll go, oh, okay. So if you see me miswrite something that is very obvious, just know that the copying is really hard for me. Okay. Now, let's try something. So let's write a sentence, right? Let's say 5 less than 2 multiplied by 6 is what number? I'm just gonna put that up there and we're gonna talk about it in a second. Go ahead, copy that. Oh, you know what? I'm sorry. Don't put the than. Let's just do 5 less 2. Don't put the than. Just put the 5 less 2. Oh, I'm sorry. We can, go ahead, just keep it in. Just keep it in. I'm sorry. We'll keep it in. Okay. It still works. Now, I'm going to rewrite this in two different ways. I'm going to put commas here. So I'm going to put, so we haven't done this one yet. And I'm going to show you that the answer to this is ambiguous. It depends on how you read it. Now, if I'm writing too fast for you, go, oh, could you stop for a second, or could you let me catch up? Just let me know, and I'll stop for a second. Now, in this one, I'm going to put a comma here. Then we're going to do another one. A little bit lower. Put the comma right here. Now, there's a couple things that we want to be able to do. Okay? The first thing we want to do is first find which word means equal. Now, I should have given to you this in the beginning. Let me see if I can find it. I think I emailed this to you. Give me 1 second. So I'm going to put this in the chat. I'm going to go ahead and download that. And let me share a screen. Okay, now, this is a good reference of what each word means. So usually the ones that people don't understand is quotient. Quotient means division. Product means multiplication. Okay. Total means addition. Okay. So when you're working on the translation problems I give you and the translation problems you see in your workbook, this is a good sort of reference as to what the words mean. Okay. Now, the first thing we want to do is look for a word that means equal, right? Equals, yields, gives, is, was, amounts to, is equal to. We're looking for that. That's the first thing we want to do. Okay. So step one is find the word equal. So in each one of these, find the word that means equal. So in this case, it's the is. Now, the reason why we want to find the equal is that it cuts down how complicated this is in half. So now I can look at this half of the problem without looking at this half of the problem, because in between I have a equal. Now, when you say what number, Well, what number is, that's just the variable. So what you want to do is treat this as two separate problems initially, right? Everything on one side of the equal and everything on the other side of it. Right. Now, the next question is, I have two operators here. I have a less than, and I have a multiply. And the question is, do I do the less than first and then multiply it? Or do I do the multiply and then do I do the less than? Well, if there are commas, the commas tell you where the parentheses go. So over here, the 5 less than 2, it's a grouping because I have a comma here. Over here, the less than 2 multiplied by 6, see, it's over here, right? Well, I guess maybe I'll put the comma. No, I think the comma's supposed to go 5 less than 2 multiplied by 6. Okay, so the parentheses will go there. Okay. And then you just fill in the numbers. So this one will be 2 times 6. Now remember, than means reverse the order. So this minus will come afterwards. Okay. That's why this 5 got moved over here. Now do the same thing over here. Do 5 less than 2 inside of the parentheses. And then multiply it by 6. Now, I already know some of you are going to be secretaries. I'm going to say, try to do this part, inner part, and you're like, no, I'm not. Just going to watch you. I'm going to copy what you write. The reason why is because I like clean notes. Okay. Now, you'll find that as much as possible, I'm going to explain something and say, now you try it on something slightly different, not the same. And then I'm going to then correct you. And you go like, well, are you doing that to be a jerk? And I'm doing that, no, to create a long-term memory. Now, if we had this conversation where I go, do you remember your last boyfriend or girlfriend when you guys broke up? Do you remember what happened? And most people go, oh my God, yeah. And are there certain details that stand out? I remember what he said. I remember what he was wearing. Maybe you remember what he smelled like. Maybe there's some little detail where you're like, oh my God, I will never forget this one thing about when you broke up. Okay? He had the gall to mention this. Now, the reason why you remember is because when something's going smoothly, there's no memory being created. But when you make a mistake and you have that feeling, it creates a long-term memory. Okay. What I'm trying to do is find the places where your intuition has betrayed you. I think it works like this. let me just try. My first instinct was to do this. And then when I correct you and you go like, oh yeah, oh yeah, oh yeah, or oh yeah, that's right, he said this. When that feeling, that frustration feeling of, oh, I got it wrong, is a memory being created. You don't create memories when you're copying something. So I can do this all I want and say, go ahead, try. And then you go like, no, I'm just gonna wait. Oh, look how nice my notes look. All you're gonna have is pretty notes. You're not really gonna pass this thing because we're not doing the thing where you're here because there are certain things in math that intuitively you do that are wrong. And we need to find those things, correct it with these small little moments where you go, so that on the TEAS test, you remember. Okay. So when I say try it, if it's wrong, it's wrong. It's not a big deal. But that feeling will make it a memory. Now I can even prove this. So if you had a boyfriend or a girlfriend and I go, what happened on your 6th date? You know, 6th date. I remember my first date. We went here, second date we went there, third date we did this. When it gets to about 6, I'm pretty comfortable. First date, I'm pretty nervous. Second date, I'm nervous. Third date, I'm nervous. 6th date, we had 6 dates. I'm feeling pretty good. I'm pretty relaxed. And that's why you don't remember what exactly happened on your 6th date, or you remember what happened on your first date, because there was so much tension there. Okay. So what we're trying to do is create that artificial tension by making you do the problem first, and then by correcting you. That's what we're trying to do. Okay. So remember that this said then, and we're doing inside the parentheses first. So what's going to happen is that 5 and 2 are going to switch places. Okay. So we're going to go 2 minus 5 times, let me change that. 2 minus 5 multiplied by 6. Okay. Now you'll see that depending on where you put the parentheses, you'll get a different answer. So for example, on this one, I get 2 minus 5 times 6, I get minus 3 times 6 is equal to x, and then you get minus 18. But over here, if I have 2 times 6 minus 5, I get 12 minus 5 is equal to x, 7 is equal to x. So you can see that depending on where you put the parentheses, changes what your answer is from incorrect to correct. Now, because you're taking a multiple choice question, I can guarantee you both of these will be a possible answer for this problem up here. Okay. The question is this problem here, this one, or is this problem this one? Okay. So go ahead, copy this, and then we'll talk about that. Okay. Now, when we look at a problem that has multiple operations, but no commas, okay? So they may give you something with a comma, but I seriously doubt it. This is usually the way you'll see the problem, okay? No commas. So if we were to read this, we can infer the comma by putting a pause. 5 less than 2 multiplied by 6. Right? That's why the 5 less than 2 go together. Over here, because there's a comma, I'm saying 5 less than 2 multiplied by 6, meaning that first do this and then do that. Now, when we have multiple operations and no comma, the last operation goes first. So what I usually tell people is start from either the end or from the equal and go backwards. And you do this operation first. Okay, so step 2, do the last operation first. So in this case, if we were to do the last operation first, we would do this multiply first, and then we do the less than. So this is the same thing as this. Right? You always do the second operator first. Now, my board is messy, so I'm going to erase this, make sure everyone can copy it, and then I'll put a new question. We'll do it together. Does anyone need more time to copy?
I'm fine.
Okay, let's take a look. All right, so let's do some problems. So for these translation problems, I've basically given you all of the sort of tricks, right? Do the last operation first. That tells you where the parentheses go. And then look for the keywords then and from if they're trying to reverse the order. Okay, now, so let's look at something that looks like the sum of a number times 6 and 8 yields the quotient of 10 and 2 plus okay, let's try that one. Okay. So go step 1, find the word that means equal. So the word equal is here. Now over here, you have addition and you have multiplication. So you're gonna be doing the multiplication first. Okay. Right, you're gonna be doing this one first, right? Times. So figure out what that means. What is inside the parentheses here?
Would the parentheses be like 10 times 8?
We'll see right here. It'll be right here. So this. Okay. So here's multiply. Does that make sense? The sum of,
Yes.
right. So you're looking for that little sort of sub paragraph that tells me to do one thing, a number times 6. Okay. Now do the second part. Okay. So we're doing this first. Now sum it with 8. So sum means plus. So you keep the same order. Now do this one again. Last operation first. You got a plus and you got to divide. Go backwards. So where the parentheses go is 2 plus 1. And then we'll keep the same order. Quotient of 12 divided by 2 plus. Okay. So you have this. You have 6x plus 8 is equal to 12 divided by 2 plus 1. So go ahead and solve that.
Professor, real quick, that 12 divided by 2 plus 1, it can be also 2 over 2 plus 1, right?
Yeah. This right here is the same as 12 divided by 2 plus 1. Absolutely.
Just thinking, just in case they have it in a different way in the test.
Sure. Yeah, absolutely correct. Yeah. So we'll solve this. 2x plus 8 is equal to 12 divided by 3. 6x plus 8 is equal to 4. And then we'll subtract the 8 from both sides. And we'll get 6x is equal to minus 4. X is equal to minus 4 divided by 6. Okay. Oh. So we'll copy that and then we'll do another one. We'll do a few. So I'm going to leave this part here for you to copy. Put the new one. And let you try. Oh. Six. Let me get out of your way. Go ahead, copy, and then go ahead, try that. Right? First, find the equal, and then remember that the second operator is what you do first. Right? So let's look at the word that says equal. So same as means equal. So twice means multiply, plus means addition. So the parentheses should go around the second one, right? Addition. So we're looking at this right here. 6 plus a number. So this is 6 plus x and then 2 times. Now do the same thing here. So when we say triple, it means 3 times. So let's look at this one. So we have subtract from, and then we have triple the same number. So what we want to do is the last operator first. So we want to do this one, triple the same number. 3x. Now, this over here says reverse the order. So this 5 is going to go over here. So we have 6 plus x is equal to 3x minus 5. So go ahead, solve that problem. Okay, so let's distribute. So we get 12. That, right? Minus 2x minus 2x plus 5 plus 5. X and equals 17. Okay. Try another. So let's try 6 times 8 plus then the number is the same number multiplied by 5 minus 8. So first find the word that means equal. So let's erase this. So is the word that means equal. So let's go backwards. We have a subtraction and we have a multiply. But we're going to do the subtraction first. Now, because it has the word than, we're going to reverse the order, right? We're going to go x minus 8. And then we're going to 6 times it. Now let's do this over here. Right, we're going to go backwards. We have a multiply and a subtraction, but we do the last one first. So we're going to go 5 minus 8. There's no than, there's no from. So we don't have to do any kind of, we don't have to do any kind of, we just keep the same order. And then we multiply with x. So go ahead and solve this problem. Now, to make your life easier, I probably wouldn't distribute the x. I would just go 5 minus 8 is equal to negative 3. So you get negative 3x. I think it's easier just to do this. So go ahead and finish that up. So we get 6x minus 48. And I will subtract 6x on both sides. And I get minus 48 is equal to minus 9x. So x is equal to minus 48 divided by minus 9. It's equal to 48 divided by 9. Okay, let's take a 5-minute break. We're in a good place right now. Let's take a 5-minute break and then we'll probably get started again at 9 o'clock. Okay, so go ahead, run to the bathroom, get some water, pet your dog, hug your kids. Okay, so let's get back to it. We've got another big chunk to work on, and that's ratios. We're not gonna rush. You're probably gonna get one of these problems, absolutely. Then in terms of ratios, you might get one, you might get three. So ratios is something we're gonna have to be comfortable with. Now I know that everyone is nervous about percents. That's usually the first question where I go, what do you guys want to learn? And I know that percents is usually the first thing. So we're going to warm up to it. Most likely week 3, either next week or in 2 weeks, we're going to do percents. And then usually at the end, at the wrap up, I do percents one more time, only because in terms of the word problems, the one that seems to show up the most that students get wrong are percent. So we'll spend an entire 2 hours plus a little review at the end on percent. Okay, so we're going to get there. Now, what we're going to work on first are ratios. Now, unfortunately, okay, the way, so I'm going to apologize in advance. The way proportion questions are often asked are in terms of proportion of men and women. So the assumption is that men and women are binary. Okay? Now, in today's world, we've kind of become a little more enlightened to realize that there are people who are non-binary, who don't associate with one gender or another, or gender fluid, who don't associate completely with one or another. Okay, so I agree. I am with you. Okay. Now, unfortunately, the way statistics are written, the statistics books, oftentimes these questions, they are going with the old paradigm that if you're not a man, you're a woman. Okay. So if we do a problem that is written that way, understand that I'm only doing it because this is how it would be written on the test. It's not a statement about gender politics, right? It's just an unfortunate legacy that hasn't been resolved. And from what I've understood, just looking at the literature, just trying to find literature about it, there is no attempt at this point to like fix that within statistics. Okay, so let me just sort of preface that, okay, that we'll get boy and girl questions, and we're going to assume that those are binary choices. If you're not a boy, you're a girl, okay? But it's not a political or a sociological statement on my part. Now, let's talk about ratios. So ratios work this way, right? You have, let's say, a total of let's say 12 students. You have in terms of boys, you have let's say 8, and in terms of girls, you have 4. Okay. So basically, these are the 3 numbers you get. You get the total, right? The total number of students. You'll have the number of boys, the number of girls. And usually, well, not usually, always, they'll give you one of these, I'm sorry, 2 of these numbers, and you're asked to find the third. Okay, so that's how these problems work. Now, let's say I start anew and say that there is a 3, we can write like that, or 3 to 4. That's how we write a ratio. Oh, even before that, let me answer a few questions. What is the ratio of boys to girls? Now, the first one is the numerator. The second one is the denominator. Now, we want to think of this as a fraction. The first one is the numerator. The second one is the denominator. Once we think of it as a fraction, what we want to do is we want to simplify. So my ratio is 2 boys for every 1 girl, or 2 to 1. So you always have to simplify this as if it was a fraction before you give your answer. So I'm going to give you 2 problems where you convert to a ratio. What is the ratio of boys in the class? So now you're doing boys to the total number of students in the class. Ratios, the word proportion, they mean the same thing.
For the third question, what does it say at the end? Just because in my screen it's kind of blurry.
Oh, say that again.
For the third question, what does it say at the end?
Oh,
Girls
total
to.
number of students.
Okay, thank you.
That R looks pretty hokey. So let's look at this one. So that's the numerator, that's the denominator. Okay. So the numerator is 8, and the denominator is 12. So this is 2/3. So 2 out of 3. Okay, I'll go ahead and do this one. Now, they could give it to you as a fraction also. So sometimes they'll do a fraction. But I just want to show you this notation that this right here means the same thing as a fraction. So your answer could be a fraction, or it could have the colons or the 2. Then over here, total number of students is 4 to 12. 1/3, so it's 1 to 3 like that. So go copy that. Let me. Now, let's see. Now you're gonna round to the nearest girl. We don't cut girls in half. You can't have 7.3 girls, right? So if you get a decimal, you need to round it if it's appropriate, right? So we don't talk about like proportions of a human being, right? So round to the nearest girl. Let's look at this. So, what we want to do is we want to say there's 22 boys. Now, for every 3 boys, there are 4 girls. So, right, we keep the same order. So we go 3 boys and then 4 girls. Now, if you had done boy, boy, girl, girl, that works also. Now, the way we're going to solve this is we're going to cross multiply. Okay. So for some of you, you may have been taught, oh, I do 22 boys over 3 boys equals X girls over 4 girls. So if you do it this way also, once we do the cross multiplication, you'll get the same answer. So they're both ways are fine. Okay. So what we want to do is when we have a fraction equal to a fraction, we can cross multiply it. This times this times this. Okay. So I have so the easiest way to do it. Is I want to have X in the numerator, and I want X in the numerator, and I want all my numbers on one side. So the easiest way of doing it is not to do algebra, but just to move the things that make it so all the numbers are on one side. And my X is on the other side. But you want to make sure your X is in the numerator. Okay. So I don't have to move that 22 if I don't want to. So I have 22 times 4 divided by 3 is equal to X. And that just saves you a little bit of time. So X is equal to 29.3 is equal to 29, because we don't cut girls in thirds. Okay. Now you could see that if I did the same thing over here, the only thing I'd have to move is this one right here. And I would get the same setup. Let's try it again. Let me give you a new one. So let me say, if there are 38 girls, how many students are in the class? Okay. Okay. Now, the problem with this problem is that my ratio is boys to girls. So you give me boys, I can tell you how many girls there are. You tell me girls, I can tell you how many boys there are. Which is fine, because if I know how many girls and how many boys there are, I can add them, and that'll tell me how many students I have. Okay. So in this case, our ratio does not connect to total number of students, but we can find it by doing an addition. So go ahead and find how many boys there are, and then add that to the girls, and then that'll give you the total. Okay, so go ahead, do this to find how many boys there are. Okay, let's take a look at it. So let's see how many boys are on. Okay. So I have 38 girls. And I don't know how many boys are on. But I do know that I have 4 for every 4 girls. I have 3 boys. Now, if you had done it the other way, where you put the X boys over 38 girls and 3 boys over 4 girls, like you took the reciprocal of both of these, you'd get the same answer. Once you do the cross multiplication, you'll get the same thing. So I want this to go here, I want this to go here. And I will move the boys up. So there are many ways you could have set this up, but at the end of the day, you should have gotten something that looks like this. Oh, I dyslexia. There we go. So as long as you got something like that at the end, you did it right. Okay. So let's see. So X is equal to 28.5 is equal to 29 boys. So if you have 29 plus 38, so if we add the boys to the girls. Let's see how many we have.
Professor, question.
Sure.
On that 28.5, on the test, I believe, and please correct me if I'm wrong. My understanding was when it's 28.5, you go to the lowers to the next number, which I thought it was 29 like you had it, but sometimes it comes out to be 28. Just an example.
Oh, I see what you're saying. It depends on the question. Usually you have to round up. Okay, so let's see. We'll put 67. Let me see. It depends on the context of the question. So you're asking something really smart. Okay. So if it's something about safety, right? So let's say you need 5.2 columns to hold up a roof. Okay. So if you have 5 columns, even though you round it and it's 5, the roof is going to fall. So in terms of safety, I want to add 1. So if I need 5.2, which means that I need more than 5 in order to hold this roof up. So it depends on when you read the question if it has to do with safety. So if you have something like give let's say 5.6 ounces of meds to a baby. Okay. So let's say you calculate how much medication you're supposed to give to a baby, and it's 5.6 ounces, but you're only able to measure in ounces because you're using a syringe. Well, let's do mLs. Because your syringe only measures in mLs, then at that point you may just give 5 because you don't want to over medicate the baby. You don't want to give the baby 6. So does that make sense? So sometimes in terms of safety, they'll ask you to round up or round down because either I don't want to give too much or I have to have more than this in order to make sure everyone else doesn't die. Right? It's always better to overbuild or under medicate. So that's one
So
way.
it just depends on the situation, depends on the question, like you said.
Yeah, it really has to do, those always have to do with safety. Right, so you always want to overbuild, under medicate. Okay, but great question.
Thank you.
Okay, now. Okay. So let's try another one. Okay. So understand again that we're gonna get, we'll do no. So let's say, there is a ratio of 2, 3, 5 yellow, blue, and green balls in a bag. Then we'll say if there are 13 blue balls, how many yellow balls? And then remember, we can't have half a ball. Either we have a ball or no ball. Okay, so you have to round it to the nearest ball. Now, when you do this, right? So remember that this is yellow, blue, green. So just use the two that you need. You just need blue and green. Okay. So in terms of blue, so we have 13 blue. And I don't know how many green. Again, you could have this opposite also. I don't know why I put it on the bottom, but I always put in the order that comes in the question, but you don't have to. So blue is in the middle. And then green is the last one. So I'll bring this up, right? We go diagonal. Bring that down. And I'll bring this up. So I have X is equal to 13 times 5 divided by 3. I think that's 12. Let's see. 13 times 5 divided by 3. Okay. So this is equal to 21.6 is equal to 22. Okay. Let's do one last one. So let's use the same ratio. So, so let's use the same ratio here. If there are 18 green balls, how many total balls are there? Go ahead, give that. It's a little bit harder. Now, if you're a little bit stuck on this, okay, remember that when we're doing ratios, we only have two items. Like, so for example, I have blue and green balls, ignoring the yellow. So the only way to know, well, I guess there's a couple ways of doing it. One way to attack this problem is to say, well, I know how many green balls there are. So let me figure out how many blue balls there are by how many green balls there are by doing this. And then let me find out how many yellow balls there are by doing this. But another way to attack this problem, which is a little bit easier. So this tells me how many green balls there are. So when there are 5 green balls, there are 10 total balls. So while you could figure out how many blue balls and yellow balls there are independently and then add them, it's probably faster to go green balls, total balls, and then do that ratio. So go ahead and give that one a shot. And if you say, could we have done that in the previous question? Absolutely. Why didn't we? It took the same amount of time. But when you start getting multiple balls, it's a little bit easier this way to do one ratio once. Okay, so let's take a look at this. So I have 5 green balls. Over 10 total balls. Then we're given 18 green balls. And then we have X total balls. So let's say this will go up. Oh, sorry. This will go up. This will go down. And then this X will go up. So I have X is equal to 18 times 10 divided by 5. It's equal to, I guess, 36. Okay, so now that one is done. Now, the next thing I want you to look at, I'm going to put this in the chat, is I want you to look at we're going to do unit conversions, okay? Meters to yards and such. Okay, now you're probably going to get one of these questions. Please memorize this table. I'm going to put it in the chart. It's not this was not in a your TEAS, but this is from a previous TEAS, and they basically recycle questions. Okay, so I put it in the chat. I also emailed this to you. So we're going to need this conversion chart, this one right here. Okay. Now, we have 2 different measurement systems. We have the English to metric and the metric. Now, as a nurse, these things are not exactly the same, but they're going to make you, they're going to have you memorize it this way. So you're going to say 1 yard is equal to 1 meter. 1 quart is equal to 1 liter. And then 1 kilogram is 2.2 pounds. So if you want to go from metric to English, what you want to do is convert everything to a meter, and then say 1 meter is equal to 1 yard, and then from there convert to English, whatever, feet or miles. Okay. Same thing with volume. You can assume that 1 quart is equal to 1 liter, even though they're not exactly. This is what you will use as a nurse. Okay. Now the reason why I'm telling you to memorize it is that 2 weeks into entering nursing school, you're going to have a unit conversion test, and they're basically going to say memorize that. We don't have time for class for you to work with you in class on this. You should know this. Okay, so if you get accepted, first thing you want to do, you might as well memorize this now, because while you're in the stress of starting your nursing program, they're going to make you memorize it anyways. Okay, now let's look at how to use this. We're going to do what's called multidimensional analysis. It's a big word for something that's not that bad. Now, don't copy this. If I asked you to do something like this, oh, sorry, let's make that a 6. What you would do is you would say, oh, I'm going to multiply this by 3 over 3. And that'll give me 3 over 6 plus 1 over 6. And you go, why did you do that? It's like, well, I needed a common denominator. I needed both of these to be 6. And then you would say, well, why did you put a 3 on top if only the bottom needs to be a 6? And you said, well, 3 divided by 3 is equal to 1. And then when I multiply 1 by a half, I get 1 back. So I have to multiply something equal over something equal. Otherwise, it changes the value of the number here. See, when I simplify 3 over 6, I get a half. Okay. So we use this idea when we convert units. And you probably did this in chemistry. Okay. So if I say I have 1 foot is equal to 12 inches. Well, I can use this relationship of 1 foot over 12 inches is equal to 12 inches over 1 foot is equal to 1. Okay, this part you can copy. So in this relationship, it doesn't matter which one is on top and which one is on the bottom. At the end of the day, 12 inches is equal to 1 foot, so they're equal to 1. So if I want to convert 36 inches to feet, I would do 36 times, inches times, and I need to have inches on the bottom, feet on the top, so that'll equal feet. I need what's in the numerator here to be equal to what's on the denominator over there, because I need them to cancel. So these two cancel, so that's my unit. Now, I could do this opposite. Go ahead and do that one. Don't do it in your head. Do it by the way I wrote up here. Right? Do it the way they taught you in chemistry. Because I'm going to give you longer ones where you're going to need to. So over here I have 2 feet. Then I need feet down here and inches over here, because I need this to cancel with this. Okay. All right, now let's do the whole shebang. Okay. Let's go 70 feet is how many centimeters? Now remember that you want to go from yards to meter. That typically is the way you go from English system to metric system. Okay, so you want to go from feet to yard, then yard to meter, and then meter to centimeter. Okay. So you want to start with 70 feet and then multiply it. So the feet get canceled and then you have yards. And then the yards get canceled and then you have meters. And then the meters get canceled, then you get centimeters. Okay. So over here is the English to metric translation. Oh, I just converted. See if you can do it. I'm going to run to the restroom real quick, and then I will I'll do it for you, okay? All right, let's keep going. So we're starting with 70 feet. Okay. So I need this to be feet and then yards. And then I need this to be yards and then meters. And then I need this to be meters and then centimeters. Okay. And the idea is that these two will cancel. These two will cancel. And then these two will. So I have 3 feet is 1 yard. 1 meter is 1 yard. And then 100 centimeters is 1 meter. So now you get 70 times 100. So you get 2333.3 dash centimeters. Okay. Now, if you wanted to go from feet to inches equal 2.54 centimeter, that's okay too. Nothing wrong with that. But that just means you have to memorize 2 things. If you convert everything to yards, then it'll always work. But if you want a shortcut to 1 inch is equal to 2.54, because that's something that you already know, no reason why you can't. Now, let's do volume. So let's go from metric to English. So we'll say 2,500 ml is how many? Let's call it ounces. And if you say, is this something very typical for nursing? And absolutely, the answer is absolutely. And if you say, are there more units I have to memorize? And the answer is yes. You're gonna have to memorize tablespoons, teaspoons, right? Because when you medicate someone, you give them a spoon sometimes. So it's really important that you memorize this now. Because it has to be natural. Let me tell you how strict they are. They're going to give you a dosage exam where you convert units in every final and in before you enter the class, right? So in the beginning of each semester. If you get one wrong, they flunk you out of the program. So you're allowed to take the exam 3 times. And after the 3rd time, if you're not getting the units right, they just say you're too dangerous to be a nurse. So if you say, of everything I'm learning, what will I really be using in nursing class? This is like the only thing, this right here, nothing else. Okay. And they're really strict about it. When I asked them, how come you're so strict about if you flunk the exam 3 times and one wrong answer is a flunk? Why are you so strict? And they always ask me, how many patients are you allowed to poison? 30%? Are you a C nurse? So you get to poison 30%? And the answer is none. 0. You don't get to poison anyone ever. The one thing you can't ever get wrong is this. If your doctor says this is how much medication the patient gets, and you only have something that measures ounces, you better not get that wrong, right? Because they're taking medication. Okay, go ahead, do that. Look at this. So we have 2,500 ml, 1,000 ml is equal to 1 L, 1 liter. And then 1 liter is equal to 1 quart. And 1 quart is equal to 2 pints. And then, oh, I'm sorry, I have to go to cups. No, yeah. 1 pint is 2 cups. And then 1 cup is equal to 8 ounces. Let me make sure I'm right. That looks right. That looks right. All right, 2 pints is 1 quart. 2 cups is 1 pint. 8 ounces is, okay. So let's multiply this out. So I have 2.5 times 32. Okay, so I got 80. Okay. Now, I'm going to stop the recording.